Good evening. Good evening to all of you. Welcome you guys. Welcome you all. I hope we are live. So here, please do check the audio video. Is it fine to all of you? Am I audible to all of you? Check the audio video is clarity. I hope we are live. Welcome you guys. Welcome you all. Welcome to Unacademy. Welcome to the Kreatryx. So check this audio video is quality. Am I audible to all of you? Tell me. Done? Chalo. So let's continue our discussions, all of you. Let's continue our discussions, all of you, everybody. Chalo. Now, and we have a great announcement for the all the aspirants of GATE 2024 and 2025, and we are starting a new batches. We are starting a new batches. You can have a look at here, and these are the new batches we are starting. And you can see the top educators of Unacademies are in the single frame. You can find out here, right? So the batch which is starting from the December 24th onwards, you can have a look at now here. So this Umesh sir is starting the networks, and you can find the top educator teams. You can find the single frame, and so these are the new batches we are starting for the 2025. You can find the top educators in the single frame. Now these are the advantages of joining these batches. We can cover the complete syllabus in detailed manner. You can access all the digital notebooks. You can access, and nearly 5,600 plus practice problems are available, and daily practice session and exclusive batches for the live classes. And you can have the test series prepared by the top educators, right? And these are the new batches we are starting for 2024 for electrical के लिए. You can have a look at, and you can do enroll for these batches. So by using a code of BV Reddy. With this code of BV Reddy, so this is, once you have used the code of BV Reddy, then you will be complete preparation is controlled by me. So here I will take care of your complete preparations. I will daily, I used to be regularly, I used to monitor your preparations and all. And you can see now these are the new batches you can see for the GATE 2025, right? And as you know, for the students of GATE 2024 to experience a real GATE and to know where you are making the mistakes and all, we are providing so this all India mock test. So this mock test is completely free for all the students, and you will get, so these are the dates you can see now here. This coming Sunday we have a mock test we have, and the test was prepared by the top educators of Unacademy, and complete detailed solutions, video solutions also आपको available होगा. Fine, all of you tell me, right? So here all of you do enroll for this mock test, and the link given in the descriptions. Link given in the description, and you can follow me in the Unacademy as well as Telegram channel. You can follow me, search in the Telegram channel BV Reddy GATE. You can get in the Telegram group. In the Telegram, you can simply search BV Reddy GATE. You will get the problems DPP आपको मिलेगा. Search in the Telegram app BV Reddy GATE. Complete full notes available there, and the notes we can upload in that group. And you can, to join in this, you can use a code of BV Reddy. By using a code of referral code BV Reddy, so I will take care of your preparation. So we used to handle the maximum subject, I will handle it. Fine, all of you. So last we have completed the about the electric dipole and we have seen some problems. Chalo, let's continue today. Today we are going to talk about the next topic, that is called as a method of images. Today we are going to talk about the concept that is called as a method of images. So see this thing, let's have a look at now what is method of images and will detailedly we are going to analyze it. Listen carefully. ये मेथड ऑफ इमेजेस का कॉन्सेप्ट आपको कहाँ से मिला? यस, लुक एट नाउ हियर. Consider this is my some conductor surface. The below part is a completely a conductor. What is this? Below part is completely a conductor. Below part completely a conductor. As we know, the conductor is a equipotential surface. Conductor is a equipotential surface. This part is a conductor. Conductor is what? Equipotential surface. Now this conductor, one end I have connected to ground. The one end I have connected to the ground. When you have connected to ground, as we know, conductor potential, ground potential is 0 volts. Then as a result, what happens now here? The potential at any point on the conductor surface, everywhere potential 0 hoga na, tell me. The potential at any point on the surface at each location, and conductor is an equipotential surface. The potential at this point, at this point, at this point, everywhere must be 0 hona padega. हाँ ना बोलिए यार. The potential at every point must be 0 होना पड़ेगा. Now अभी देखिए क्या होगा, you tell me. मैंने एक पॉजिटिव चार्ज, हाँ, consider some positive charge Q. Let us consider this positive charge Q have placed, let us consider some finite distance. So finite distance of D have placed my charge. That means the distance from the point charge, the charge to the conductor surface is exactly something D. Now at this location, at this point, let us call this point is something A. At this point I want to find the potential. As we know, the potential due to this point charge, the potential due to the point charge, which is given as what we can say here, that is KQ by D. All of you boliye, potential due to the point charge which is given as KQ by D. But लेकिन अगर आपने ध्यान से देखा तो here, where is this point A? Tell me, this is on conductor surface. This conductor we have connected to ground. Because we have connected to ground, the potential at any point on the conductor surface must be same होना पड़ेगा. The potential at any point on the conductor surface must be same since we have connected to ground. So according to the fundamental analysis, what I can say now here, how much the potential at the point A must be? The potential at the point A must be equal to 0. Now that's what we used to consider. Now all of you बोलिए. Now अगर आपने ध्यान से देखा तो इधर you see this thing here, क्या होने वाला? This means this is VA is a potential at this point and this VA is also potential at the same point. So you see this thing here, single point should not have a two different values. Single point should not have a two different values. Hana boliye. So that means there will be something, some issue has happened here. Now that means these two values, both values must be same hona padega. These values must be same. That means this VA value also 0. To make this VA value 0, now see the possible conditions are K, where K value 1 by 4 pi epsilon, which is non-zero. And what else we have? A D. We have D is a finite distance, which is a finite value, which is not infinite. And what are the Q is now? We have taken some charge Q, we have taken now. Q is also not 0. अभी आपने ध्यान से देखा तो here I need to ensure this VA also 0, but लेकिन so K K non-zero, Q also non-zero, D is not infinite, then how this VA will become 0? But लेकिन VA must be 0 होना पड़ेगा. Now you tell me now how this VA must be 0. Hmm. Did you understand what I am saying? आपको समझ में आ रहा कि नहीं बोलिए. The potential at the point A must be 0 होना पड़ेगा. But लेकिन इधर क्या होने वाला? VA non-zero. Yes, this thing here. And so this is VA to be 0, then K value non-zero, Q value non-zero. Yes, then क्या होने वाला इधर? So to satisfy this condition, so अगर आपने ध्यान से देखा तो इधर if I consider one more charge Q inside the conductor, negative charge, then at a distance of D from the charge, same distance of D. Now you see this thing, what happened? The potential at the point A, which will be the potential because of this charge and potential because of this negative charge. Now this formula satisfy now the sum of these two potential at the point A will become 0 or not. Sum of the two potential at the point A will become 0 or not. अभी देखो इधर अगर हमने ये दिस एक्स्ट्रा द चार्ज कंसिडर करने के बाद देन दिस प्रॉपर्टी सैटिस्फाई, ये प्रॉपर्टी सैटिस्फाई होगा, ये फॉर्मूला वैलिड होगा, ये भी वैलिड होगा, दोनों सही ना बोलिए. इसीलिए ये कॉन्सेप्ट हमने इंट्रोड्यूस किया, दिस इज कॉल्ड एज ए मेथड ऑफ इमेजेस, आर ऑल्सो कॉल्ड एज ए इमेज थ्योरी. Method of images, or we can call this as a image theory. So what I can say now here, whenever if I place any charge on the surface of a conductor, what happen, tell me? This conductor will induce an image charge. The conductor will induce an image charge, and the polarity of the image charge, is what you tell me? The polarity of the image charge is what? Opposite to the original charge. The polarity of this is the image charge. What is this here? This is a image. This is a image charge. The polarity of the image charge is what you tell me? Opposite to the original charge. And here this is the original charge. This is the original charge, and we need to locate the image charge. Image charge must be present inside the conducting region, where the image charge must present inside the conducting region, and we should take care of this image charge. Location must be take care such that on the surface of the conductor the potential must be 0. Potential must be 0. Is it fine, all of you? बोलिए. Is it fine, all of you? This is a concept of method of images. फाइन, ये कॉन्सेप्ट आपको समझ में आया? ये मेथड ऑफ इमेजेस का कॉन्सेप्ट कहाँ से आया, क्यों हमने ले लिया? डन. चलो चलो. Now if I have considered the conductors, we have like this. I have two conductors are like this. Now this conductor which is grounded. Now you see this thing, this right side part we have now, this is completely a conductor, which is a thick conductor we have. This is a thick conductor. I have a charge Q. I have placed on this charge Q is placed. Original charge Q distance per higher surface per. Original charge must be here. This is the original charge. This is the original charge. Now this original charge distance from the conductor surface is D. The distance from the conductor surface to this point to the charge is D. Right. Now let us consider the charge Q, which is at a distance of A from this conductor, and this is at a distance of B from this conductor, which is at a distance of B from this conductor. Now let us start analyzing the images. Now here you see this thing, this complete part, we have a conductors now here. This conductor, the free body diagram will draw for the analysis purpose. We'll draw the free body diagram. The free body conductors will be simply taken as a zero potential lines. Conductors are taken as simply a zero potential lines we can take. So these are the zero potential lines. And so potential at any point on this potential, this is the free body diagram. How much the potential everywhere? Zero. This potential everywhere, this point is what you tell me? At every point on this conductor, so the potential is zero. This is a free body diagram we are doing. Now I have original charge. This is my original charge Q, and this is at a distance of what you tell me now, A from this conductor, and at a distance of what you see this thing here, this is B from this conductor. अगर आपने ध्यान से देखा तो इधर, so because of the charge, this is my original charge. This is my original charge. Right. Now you see this thing, because of this original charge, so that means here we have the effect on this conducting surface now. So because of this charge, we have some potential will be developed, but this is the zero potential line now. Whatever the effect caused by this charge, to nullify this thing, what I need to do here? So we need to introduce one image charge here. Now tell me, we need to introduce one image charge. So you tell me now here, how much this image charge and what the distance of this image charge? Here the magnitude will be a, so to nullify this effect of this Q, we should consider if it is plus Q minus Q, then only will be effect will be nullified now. And how much the distance I should locate now from this conductor B? Hana boliye dekho. The effect of, because of this only I can able to nullify the effect of the original charge. Fine. Now here the charge can able to produce some effect on the conductor surface, or to nullify its effect also. So to nullify its effect, now you see this thing, produce one more charge here at a distance of A, then only I should able to nullify this effect now here. A minus Q. Hana boliye. Is it fine all of you? Now here this is what charge you tell me now here. Here this is a image charge. This is a image charge. Now this is also image charge. And this is also image charge. Here you see this thing, even though these are the image charges, now you see this thing here, this image charge will have some effect on this conductor surface. This will create some potential on this conductor surface. I need to nullify the effect created by this image charge on this conductor surface. To nullify this thing, what I need to do here? And here this is at a distance of how much you can see now, B distance. I need to introduce one more image charge now, tell me here. with a distance of b बोलिए. Now tell me what is the polarity of this image charge. So now this is the image charge will, this minus q, this image charge will behave like a original charge for this conducting layer. So as a result it should be a plus q होना पड़ेगा बोलिए. And if you see carefully, this effect of this thing on this conductor which is at a distance of a, this effect was nullified by this fellow na here. This distance is a na, it is nullified by this fellow. Now this is what charge here, this is image charge only, this is a image charge only बोलिए. Now you can see now here. So then the system, then because of this system there is no effect on the conductor surface. Because of this thing we can say there is no effect on the conductor surface. You tell me. Done all of you? Right. Then the system will be under balancing condition. Can you tell me how many image charges we have here? Can you tell me how many image charges we have here? Can you tell me how many image charges we have? Tell me. We have totally 3 image charges we have. How many image charges we have? 3 image charges we have. Done? Right. And to find this number of image charges we have a one relation we have. Let us see those relations here. That is the number of image charges. Number of image charges. So here to find the number of image charges, what you will do here. So first you find out this thing n, where I am defining the term called as n. I am defining this thing here which is equal to 360 degrees by theta. The angle between the two conductors. Theta is what? Angle between the two conductors. Now we need to, after getting this theta, we need to, yes, after getting the theta we need to see, observe this thing here. If n is integer, if n is integer, then number of image charges, number of image charges is equal to n minus 1. If n is a integer, the number of image charges is given as n minus 1. If n is a fraction, if n is a fractional value, that means which is not an integer, then number of image charges which is given as step function GIF, that is greatest integer function. I hope all of you know about the concept of step function. I hope all of you know about the concept of step function. Now if we have taken this as, can you tell me what is the step of 2.1? How much this value, tell me? Step function, step of 2.1 which is equal to what, you tell me? 2. So here immediately next previous integer, immediate next integer, greatest integer function. Now you tell me, if I say this as 3.9, if I say 3.9, can you tell me the step function value of this thing? 3.9, which is equal to 3. Immediate previous integer, where GIF. So this is called as what, you tell me? This is the step function. This is the greatest integer function. I hope all of you know about the greatest integer function. बोलिए. GIF. This is called as greatest integer function. Then now here you can see now here how much this angle between the two conductors you can see. The angle between the two conductors which is a 90 degrees. If the angle between the two conductors is 90, first find the n value. N is equal to theta is the angle between the two conductors here. This is theta. Here this is the theta. Smallest angle between the two conductors, theta, which is given as what we can say now here 360 by 90 degrees. And what I will get now 4. Now you see this thing n value. What the n is an integer value. What is the n is an integer value. Then the number of image charges are how many if n is integer value. Number of image charges which is given as n minus 1. Number of image charges which is given as what? N minus 1. All of you boliye. Number of image charges. Number of image charges, since n is an integer value which is given as n minus 1, which means 3. Done. So like this we need to do it. Right. Yeah, so here whether this method of images is applicable if it is not connected to ground or not. Yes. Even though if the conductors are not connected to ground, method of images is valid. So here if not connected, इसका मतलब क्या है? So that means let us consider I have given some supply I have given. So not connected to ground, let us say I have given some voltage I have given to here. Let us say I have given some 10 volts I have given. Then tell me now here, since the conductor is a equipotential surface, then tell me now here, the potential at any point must be at 10 होना पड़ेगा. The potential at any point must be 10 होना पड़ेगा. अगर न, so here because of the charge Q, so then it will create some potential. To nullify this effect we have considered the image charge. All of you boliye. So even the conductors are not connected to ground also, the method of images can be applicable. Right. That's what we have given a statement. Here if it is connected to ground, the potential must be 0. If it is not connected, the potential is constant, maintain करना पड़ेगा. Done? Right. चलिए. Yeah, take this problem. This is one of the very famous problem, you know. So in the last 10 years, this problem has been repeated more than 7 to 8 times repeated this problem. For EC, sometime electrical sometimes, and for GATE, ESE and ISRO, DRDO, you can find this thing more than 7 times this problem has been repeated. Okay. Done. So take this problem all of you. The force on a point charge plus Q kept at a distance d from the surface of an infinite grounded metal plate in a medium of permittivity epsilon is. Now what they are saying is, so we have some conducting metal plate, grounded metal plate. So this metal is nothing but conductor, now tell me, which is grounded. Now a plus Q charge we have placed here at a distance of how much the distance they located, they given up here. So some distance d they has located. Now you tell me now here, if any charge located on the surface of a grounded conductor, metal is a conductor only na, so then what happens now, it will induce one image charge. Hana boliye, that is minus q. This distance is d na, tell me. This distance is d. Now they are asking to find what you tell me now here, the force on this original charge due to the image charge. They are asking to find the force on original charge due to the image charge. And that force on image original charge, which is given as what we can say here, F is equal to 1 by 4 pi epsilon into, tell me now here, so here charges q minus q, here we have this is q into q square ho gaya na, by now r square. What the r is a, r means what now here, distance between the two charges. What is a r is a, r is a distance between the two charges. You tell me how much the distance between the two charges. Now here we have a 2d now distance now here, that is 2d whole square. Boliye. So that means the force which is given as, what we can write, you tell me, which is equal to 1 by, that is 16 pi epsilon q square by d square. Done. Now you tell me what could be the direction. Now tell me what is the direction of this force now here. Now you tell me now here, so this is a positive charge here, this is the positive charge now here, positive charge, this is a negative charge, image charge and negative charge. What is the force between these two here? What type of force we have? Attraction or repulsion? What type of force is it? Is an attraction or repulsion? Which is an attractive force. Now opposite polarity means attraction, so that means the force, the direction of force on this, which is this direction. Now tell me the direction of the force on plus q. Here both are positive charges. Now one is positive, other one is negative. That means what type of force we have here? Attraction, repulsion. If we have similar polarity, if the two charges same polarity, we have a repulsion. Different polarities means we have attraction. Now the direction of force is what direction, you tell me now here? Towards a plate or away from the plate? Towards the conductor or away from the conductor? Which is a towards the conductor. It is what you tell me, towards the conductor. बोलिए. बढ़िया. चलो. Next one. And take this problem. Take this problem. अभी ने इसके बारे में हमने डिस्कस किया, अभी हमने एनालाइज भी किया. सो सेम प्रॉब्लम हैज बीन रिपीटेड रिसेंटली. टेक दिस प्रॉब्लम. Two semi-infinite conducting sheets are placed right angles to each other, okay, as shown in the figure. Right, a point charge plus q is located at a distance d from both the sheets. The net force on the charge, here they are asking to find the force on which charge? On the original charge, because of the image charges. Can you tell me how many image charges we have first of all? Can you tell me how many image charges we have first of all? You tell me. तो कितना इमेज चार्जेस होगा इधर? अभी बोलिए. अभी ने हमने एनालाइज किया है ना इसके बारे में. Yes. From here to here at a distance of d, we have this charge is minus q होगा ना, and from here to here this distance is d, equal distance na, 3 image charges we have. Yes, the distances are equal, they given this is d, and here we have what charge now here? Plus q. This distance is d. and here we have this is minus q. Boliye. And here they clearly mention the x-axis, y-axis they has mentioned. Can you tell me the coordinates of this charge? The coordinates of the charge, x coordinate is d comma d na here. Coordinates of this one, the charge. So this point lies in the fourth coordinate. Fourth coordinate, x coordinate is a positive and y coordinate is a negative. Now tell me. Next, this point lies in the third coordinate. So tell me what we can call now. This is minus d comma minus d hoga na. Third coordinate. And this point, so this coordinates you tell me now here क्या होगा, which is equal to minus d comma plus d. All of you second coordinate na, everybody. Now let us find the forces now here. The charges you can see now here. Now I need to find the force on the charge q, this q, because of the all the charges, isn't it? Now this distance, if I call this is, I am calling this is 1, charge 1, this is my second charge, and this is my third one, and this is my fourth charge I am calling. I want to find the force on charge 1 because of 2, 3, 4. Due to 2, 3, 4 I need to calculate. Now let us find the distance now here. Distances we can find now here. That is my here, if I say this as R21. So this point is final point now. We will find the distances now here, which is given as final minus initial. So this is how much the distance between these two charges you tell me now here. X coordinate will be nullified. We have what we have, it is along this is, so which we have a 2d into j cap now here. All of you boliye, which is given as 2d into j cap. Next, R31, which is given as what we can say now here. So this one, this distance, how much will get now here? So final minus initial, which will get this as a 2d into I cap plus 2d into j cap hoga na, tell me. Next, R41, if I say this distance, which is given as what will get now final minus initial, which is equal to 2d into I cap. Boliye, these are the distances now here, and we can find the magnitude and we can substitute the values in the formula. The forces, if we see carefully, now find the magnitude of the forces here. So the force which is given as force caused by the second charge plus force caused by the third charge plus force caused by the fourth charge. The sum of all the forces now tell me. The sum of all the forces, isn't it? Now you can find this magnitude of the force, which is given as 1 by 4 pi epsilon. We can take outside. We can take out the 1 by 4 pi epsilon is a constant we have take outside. And then if you see here, now this is, so this q into q, this is minus q. So what will get now, minus q square by what I can say now here, magnitude of the distance. How much the magnitude distance is at 2d, means what I can say 4d square, and the direction unit vector is along what direction now, j now here, that is j cap, plus now force between this and this 3 and 1. How much this force you tell me now, magnitude of charge, which is equal to q square by, now tell me now distance, now magnitude of the distance, which is given as, you tell me how much is R31, magnitude which is given as 2d into root 2 hoga na, iska whole square, distance square means 4d, 4 into 2 8d square, isn't it? 8d square. And the unit vector, how much the unit vector you tell me now here, which is equal to unit vector which is given as I plus j by, so here that is root 2, I plus j by root 2 now here. Next, third force between the 4 and 1, which is equal to q square minus q square. So this is minus q square by, and this magnitude which is equal to 4d square. 4d square direction is what direction now here? I cap. Now here simplify, get this value. What we'll get now? I can take out the q square by, so they given here, they asking here, they has taken this whole term common, they are asking to find this k value only. This k value we should get, we should express in this form now. Q square by 4 pi epsilon into d square we have taken outside. Now you can tell me what are the terms we have, which is equal to minus 1 by 4 into j. Yes, plus what I'll get now here, that is I plus j by what I can say now here. So this is 8 root 2 minus what we'll get now here, 1 by 4 into I, and do simplify, get this value. कितना आएगा check करो. So do verify this thing here, simplify, tell me how much will get finally. Tell me the k value कितना आएगा check करो. So 8 root 2 you can take LCM now here and do simplify. क्या आएगा चेक करके बोलिए कि क्या आएगा, बोलो जल्दी फटाफट. डू सिंप्लीफाई करके बोलिए जल्दी फटाफट. आया कि नहीं, बोलिए जल्दी फटाफट. सिंप्लीफाई करके बोले क्या आएगा. डन, बोलिए आंसर क्या आया. यस, टू वेरीफाई आई थिंक ऑप्शन डी विल कम. चेक करके बोलिए, ऑप्शन डी आना पड़ेगा, चेक करके बोलिए. आया कि नहीं बोलो. चलो done. So like this we have analyzed the scenarios. Fine. अभी तक हमने क्या analyze किया? The method of measures we have analyzed for in case of a flat surface. We analyze it for the flat surface. If it is a curved surface, what happen we are going to see. अगर if it is a curved surface, अभी हम देखना. Let's see this thing, what happened for the curved surface. Yes, take this one here, all of you. Take this problem. A point charge Q is situated at a distance d from the center of a grounded conducting sphere of radius capital R. The value of the image charge Q, so at a distance b from the center, the quantities Q and B are. Okay. Now they ask into the image charge. So here take this as a capital Q. Okay, capital Q. Now they are asking what will be the image charges they are asking to find. Listen here, all of you. So previously we did the analysis for the flat surface. Now we are going to analyze for the curved surface. This is my conducting sphere. conducting sphere of radius is capital R, and this one, so this conducting sphere which is grounded conducting sphere, this radius. Now what they said now here, they placed some charge of plus q at a distance, small q they placed, a charge q they has placed. Now here the charge which is located at a distance of how much, you tell me? The charge which is located at a distance of d from the center. This is the data they has given. All of you tell me first of all, यहाँ तक clear ना बोलिए. Now if you play the charge, then we need to see this thing here. So here, what is the magnitude of the image charge and how much distance it is located? How much distance it is located? Those things we are going to find out. Right. Now you see this thing here, the image charge. Consider this image charge. Yes, where the image charge must be there, tell me. What is the condition now? Image charge must be located inside the conducting region. Keep in mind where we should locate the image charge. The condition for this now here. So here, then the conductor will induce an image charge. The polarity of the image charge is opposite to the original charge, and the image charge must be located inside the conducting region. Inside the conducting region. So we have the image charge must be there only inside the conducting region only. And here this is my conductor here. So image charge must be located. Let us consider somewhere here. I am considering. This is locating here. So this charge I am calling this thing as what we can say capital Q. This is a capital Q is an image charge. Now this is at a distance, they given this distance from center to this distance is there now. This distance I am calling this thing as something B. Now this my objective is I need to find the how much the Q value and how much the B value we need to get. Now this is here this small q which is a original charge. This is what now here original charge. Now I am doing analysis and start doing here. Look at now here. Now I am taking this point now here exactly diametrically have taken 2 points I have taken for the analysis purpose. Where I am taking up 2 points A and B, where A and B are exactly diametrically opposite points. Now I want to find the potential at point A. What is the potential at the point A? Tell me. The potential at point A which is caused by the potential because of the original charge as well as potential caused by the image charge. So tell me now potential at the point A because of the original charge which is given as what we can say here kq by, if we see this thing here, the distance from center to the charge is a q. This is the radius of the sphere. Now this is the distance now here. How much this distance hoga? I can say now this is nothing but d minus r hoga. Now tell me. This is because of the original charge. Plus now let us find the due to image charge. Now this image charge is located here. Now this distance we need. Can you tell me how much this distance now? Tell me. Kq by. So I need this distance now. This part of distance is required. How much this distance you tell me now? I can say this is r minus b hoga now. Tell me. The distance which is equal to r minus b. बोलिए. Done. This is my VA. Now see this thing here. This end. This is a conductor which is connected to grounded. Once you are connected to ground, so what is the potential at the point A? Tell me. What is the potential at the point A? Because of this, since it is grounded conductor, potential तो zero होना पड़ेगा ना, बोलिए. So it is grounded, so potential will become zero na. Now if you see this thing, can you get the relation now? K will get cancelled from this, and what we can write now here, this is Q by D minus R, which is equal to minus Q by R minus B. No, so this is the image charge, yeah. This is the image charge. We are finding here. So here the charge located not on the surface na. If the charge located on the surface, then it will become R. But it is not on the surface na here charge. So the charge Q is because of the internal charges, not the external charges. Right. So that means what we'll get now here, this is Q by Q, which is equal to what we can say now here. I can say this is R minus D by R minus B. Check here all of you. Will get this is the relation हमको आएगा. Next, I am finding the potential at the point B now here. What is the potential at the point B? Because of the two charges, original charge as well as image charges. Tell me what I will get now here. B locations. That is KQ by what I can say now here, D plus R होगा. KQ by D plus R. Center distance is D na. So plus R. Because of the image charge which is given as KQ by how much you tell me now here? R plus B होगा. R plus B होगा. Now since it is also connected to ground, the potential at the point B also zero na, tell me. By equating this to 0, we can K will get cancelled. What I can say now here, Q by capital Q, which is equal to minus of what I can say, this is R plus B into R plus D. Check all of you. Now I can say these two ratios are Q by Q only na. I can equate these two relations now, tell me. So from this, what I can say now, if I equate these two relations, R minus D, so which is given as R minus D by R minus B. If I equated these two, which is equal to what you see this thing here, minus of R plus B by R plus D, minus of what we can say now, this is R plus B by this is R plus D. Check karo. Is it fine? Am I correct now? Tell me. उल्टा एक बार चेक करके बोलिए. So I think so उल्टा लिखा मैंने. This ratio you see this thing here, this is R plus D here na. This is numerator is D, denominator is B. Okay. So this is R plus D by R plus D. Now multiply and simplify this thing here. What will get now here? Minus of what will get now here? R minus D into this is R plus D, which is equal to R plus D into R minus B. Multiply, cancel it now here. Minus of what will get now here? This is R square. So this is plus RB minus RD minus BD, and which is equal to what I can say, tell me, R square minus RB plus RD minus BD. So minus, so this is minus R square minus RB plus RD plus BD, which is equal to R square minus RB plus RD minus BD. Now check for the cancellations here. So here we'll get Mara. So here RD will get cancelled. Now you tell me what I will get now here. This is 2r square, which is equal to 2bd. That means r square equal to bd. Check it now here, all of you. R square equal to bd. That means b value, how much you tell me? B is equal to r square by d. B equal to r square by d. Now I can substitute the b value in this above equations. Any of this equation, either you can substitute in the equation 1 or equation 2 to get the q value. Now if I substitute in the first equation, q by q, which is equal to what we can say? Here we have q by capital Q, which is equal to what we have, it is r minus d by r minus b. R minus d by r minus b, where b is equal to what, tell me here? R square by d. Now I can replace now here, this is q by capital Q, which is equal to r minus d by r minus b. B is equal to r square by d. So that is q by capital Q, which is equal to r minus d by. So tell me, if I take the r common, then it will becomes what we can say now here, d minus r into d. So then from this what I will get to, tell me now, q by capital Q, which is equal to minus of, minus we can cancel it now here, d by r. From this what I can say now here, capital Q, which is equal to minus of r by d into small q. Check this thing. Minus of r by d into small q. Check karo all of you. This is my image charge. What is this? This is the image charge. And the location is what you tell me? Location where I should locate now, B is equal to, that is r square by d. Means simply we can do, remember, this is BD is equal to r square. In that manner you can remember. BD equal to r square and Q is equal to minus of r by d into small q. Done this thing everybody? All of you do like the session. So सबसे पहले like करो, session को like करो, share to the all your friends. Like the session all of you first of all. Then chalo all of you. Got it now all of you? This is one of the important thing here. Try to remember this derivation. So कौन सा option tell me now here? कौन सा option now here? How much the q value? Q is equal to what you tell me now here? Minus r by d into q na. Next what else now here? R square by d. Option A. Option A. Now take this problem. Now tell me the answer for this problem. A point charge of plus 10 microcoulombs located at a distance of 5 centimeters from center of the conducted grounded surface. B or A? B A na, not B. So this is given. So this is d square given, but r square by d na, not d square by. Now you tell me what is the total induced charge on the conducting sphere. For the charge, induced charge, which is given as what we can say, which is given as minus of r by d into q na. Tell me the induced charge. Minus of r is radius, which is given as minus 2 by 5 into q is 10. So tell me how much the charge you tell me here. That is minus 4 microcoulombs. The induced charge is minus 4. They give the magnitude only they ask na. Strictly speaking, we should have minus 4. Minus 4 microcoulombs. बोलिए. Done like this. Yeah, this is the method of images. So here this is the method of images. Fine. So here I think Himanshu, you are talking about this concept you are talking now. This is a concept you are talking. This is my sequence only, yeah. This is our sequence only. Fine. Right. And one more thing here. So tomorrow, Saturday, Sunday, we don't have any class. Saturday, Sunday, we don't have any class. Again, we have class on Monday. Again, we have a class on Monday. We have a class. And so you do follow me in the plus and as well as the free classes. You can follow me, and daily we have a classes. Tomorrow we have 11 a.m. we have a class. Daily we have 11 a.m. Right now we are doing the digital practice sessions. Right now we are doing the digital course. We are going to do digital DPP discussion is happening. Right. So you do follow in this classes 11 a.m. in Unacademy. And so in the so many classes I did, the so many special classes, so many free classes have I done. You can follow me, so many special classes we did. I did the maths, I did maths practice session I did. Next the networks practice session I did. All these are the free classes. Next signals I did, special classes, you can follow me in profile. Next I did the controls I did. Next I did the EMF I did. EMF problems I have discussed. Yes, as well as now the digital also I have discussed. The maximum subjects I am going to handle it. Yes. Yeah, this course will be keep on will continue here. Mostly in the next month also may continue, I think so. Next month also will continue until the completion of this thing. Okay. Yeah, that's for the today's session. And tomorrow, day after tomorrow, we don't have any class. Okay, we'll meet on Monday. Okay, then see you. Bye bye. Good night.